One day, this planet will see its final sunrise. It has oceans, clouds, and a warm parent star. Then one close encounter changes its path, and the entire solar system begins to fall behind. No explosion throws it away. No engine pushes it. Gravity does the work quietly until the planet is moving too fast to come home. This is Cosmion. Point it at any question in the universe, and it will show you the answer, whether you can bear it or not. Tonight, we point it at the worlds between the stars. We follow one from its birth beside a sun to the moment that sun becomes just another point of light. Planets begin inside disks of gas and dust around young stars. Tiny grains collide, larger bodies gather them up, and, across millions of years, a system takes shape. But a young planetary system is not a clockwork model. It is crowded. Orbits change. Worlds pull on one another. Large planets can move through the system and scatter smaller bodies into new paths. Our planet begins on a stable orbit. Then a giant world approaches. As the two pass, each bends the other's motion. The giant barely notices. The smaller world steals a little of that motion and leaves the encounter faster than it arrived. Its new path no longer closes around the star. The planet has crossed the system's escape speed. From this moment, every kilometer carries it farther away. At first, the loss is difficult to see. The star still looks bright. Days still pass across the surface. Seasons may continue as the planet turns and the old sunlight arrives from farther behind. But sunlight weakens with distance. Twice as far from the star means only 1/4 of the energy. 10 times farther means 1/100th. Clouds thicken, the surface cools. Rain becomes snow, coastlines lock in place, and the open ocean begins to seal beneath ice. The planet has not entered night. Night still ends when it rotates. What it has lost is noon. Each sunrise is dimmer than the one before it. Then comes the last sunrise that still looks like a sun. The star touches the horizon, crosses it, and returns on the next rotation as a brighter point among thousands. The planet still knows exactly where home is. Home simply cannot pull it back. Over time, the top of the ocean freezes. Ice thickens downward, while the rock below continues to release heat left by formation and radioactive elements. On some rocky rogue planets, that internal heat might preserve liquid water beneath an insulating shell of ice. It would not make the surface gentle, and it is not evidence of life. But it means the planet may not become completely still. The atmosphere changes too. On a small rocky world, gases can freeze onto the surface or escape. A more massive planet may hold a thick atmosphere for far longer. There is no single rogue planet. There are frozen rocks, dark giants, and young worlds, still glowing with the heat of their birth. Some may never have belonged to a star at all. They may have formed in isolation from collapsing gas, closer to the way stars form. But many should be former members of planetary systems, expelled during violent early years. Once outside its system, the planet is not motionless. It continues around the center of the Milky Way with the other stars, carrying the chemistry, scars, and perhaps the moons of its old home into interstellar space. From its surface, the galaxy would still be visible. The sky could be full of stars. None of them would rise as a disk, warm the ground, or paint a blue daytime sky. A year no longer means one trip around a sun. There are only rotations, internal rhythms, and the slow journey through the galaxy. How many worlds are traveling like this is still uncertain. Estimates range from tens of billions to trillions across the Milky Way. The range is enormous because the smallest and coldest examples produce almost no light of their own. A normal planet announces itself by crossing its star or pulling that star from side to side. A rogue planet has no parent star to reveal it. So astronomers wait for an alignment that may last only hours. Gravity bends the background star's light around the unseen planet. For a short time, that single point brightens, then returns to normal. The planet never becomes a photograph. The brief change in light is the evidence that something dark passed between us and the star. Events caused by low-mass rogue planets can last from a few hours to a couple of days. One candidate discovered this way may have a mass somewhere between Mars and Earth. NASA's Roman Space Telescope is designed to watch dense fields of stars near the center of the Milky Way, measuring them again and again. A tiny brightening that another survey misses can reveal a world with no light of its own. Roman should find hundreds of rogue planets and may detect bodies as light as Mars. That will not end the uncertainty, but it will begin turning invisible wanderers into a population we can measure. Most will remain anonymous. We may learn a mass and a direction, but never see mountains, clouds, or the place where their last sunrise happened. That is what makes them different from almost every world we imagine. A rogue planet is not waiting in orbit. It is already leaving one part of the galaxy for another, and darkness is not a phase of its day. It is its climate. Somewhere between the stars, there may be an ocean sealed under kilometers of ice, an atmosphere falling as snow, or a giant planet carrying a family of moons through a sky with no sun. And on one of those worlds, the brightest star in the sky may still be the one it lost. The lens does not blink. Subscribe, because next time we point it beyond Neptune, at the planet our solar system may still be hiding.